All right, page 208 in your textbook, unit number 6B for homework. And Jamie, we hope you get feeling better and are able to join us soon. Today, it is Quentin flying solo, so every question will go his way. Before we get started, though, we had a 3-day weekend. So, Quentin, let's review some formulas here. I know we just took a quiz on this in our last lesson, but hey, what is our formula we would use to find the length of a line segment?
V equals change in x squared, but this square root of change in x squared is change in y squared.
There we go. If I wanted to find the midpoint of a line segment,
Lowercase m,
other one,
uppercase, equals y2 minus, midpoint.
remember it's a point,
Oh,
so coordinates.
x1 plus x2, y2, and y1 plus y2.
There we go. The little m actually stands for not midpoint, but
Slope.
slope.
Y2 minus y1 over x2 minus x1.
There we go. Change in y over change in x, or rise over run. And then we had another thing that was built off the slope, because remember there's 4 kinds of slope. What are the 4 kinds of slope?
Positive, negative, undefined, and 0.
What does a positive slope line look like?
It's like going up and to the right,
This would be all your positive slopes. Negative slope looks like
up to the left.
up to the left, or it looks like it's going downward from our perspective, but up and to the left technically is a better description. Undefined?
Undefined is a vertical line.
Okay. And 0 would be horizontal line, right? So those are all the different kinds of slopes, but obviously these lines make different angles with, if you use the positive x-axis as the initial side, this would be your terminal side in each case. So positive slopes have what kind of angle?
Acute.
Acute. I was all set to put 0 to 90, but acute works, right? All of your negative slopes, obtuse, undefined, right angle, or 90 degrees, and then 0 degree angle. So again, obtuse would be 90 to 180, and acute would be 0 to 90. So what do we call this angle that a line would make with the positive x-axis?
Angle of inclination.
Angle of inclination. How do I find it? Obviously, it's tied to the slope. How do I find angle of inclination?
It's the arctangent of the slope.
Good. Alpha is equal to the arctangent of the slope. And we said that alpha then always lies between what values?
0 and 180.
Always lies between 0 degrees and 180 degrees. Or we could say 0 to pi if we wanted to use radians. And so we take the arctangent of the slope. The problem is, if you take the arctangent of a negative, it gives you a negative angle. It doesn't give you something between 0 and 180. What do we do?
Add 180.
Just add the 180. And we were using especially this concept here in the homework that you did over the weekend, page 208, 6B, so just the one problem for homework. You were supposed to find the size of each angle of triangle ABC. Now, if it said find the size of each side of triangle ABC, obviously then you'd have to use the
M equals x.
if you find the length of each side. Distance formula, right? And we've done that before, right? We've done that multiple times. Find the length of each side. No big deal there. But it says find the size of each angle. So what I suggested we do was actually draw a very accurate sketch. And it looks like you did that there on your paper. So we've got the point 1, 2, somewhere around here. The point 5, 4 would be somewhere right about here. And then the point 4, negative 4 would be right about here. So there's A, B, C. And I assume that this is where your points were. Okay. This actually looks a lot like the last one we did. Let's see, we had a 2, 3 would be pretty close. 5, 7 would be pretty close. And 4, negative. Yeah, so I was going to say, this looks a lot like the triangle we did in class on Friday, but it's just because the coordinates aren't that different from what we've done before. So to find actual angle C, actual angle A, and actual angle B, we first need to find the angles of
the slope, or
Well, the angles of inclination, and my next question was going to be, in order to find angles of inclination, we have to find the slope. Okay, so, given the point 1, 2, given the point 5, 4, given the point 4, negative 4. What is the slope of line AB?
1/2.
Oh, that's AC I was looking at. Let's try AB. What's the slope of line AB? And it is 1/2. All right, how about the slope of side AC?
2, or -2.
-2. And then what about the slope of BC?
8.
Yes. All right, once we know the slopes, we can go directly from there to the angle of inclination. So for AB, let me get my calculator. What did you get for the angle of inclination?
26.6.
26.6? All right. And then for the angle of inclination of AC?
82.9 degrees.
I did not get that. I think that's BC is what you just gave me. Hold on.
Oh, I did give B.
Yeah, 82.9 is BC. All right. And then for AC?
16.6.
Good. All right. So from here, then, if we wanted to find angle C, again, there's two lines that make up angle C. C is formed by
AC and BC.
AC and BC. So what I suggested, and hopefully you did this, is draw some kind of little alternate x-axis or a parallel down there. So you could take the whole angle here at for AC, which is the 116, and you could subtract away this piece here, which is the angle for BC, and then subtract AC's angle minus BC's angle, you get the actual angle C to be
33.7 degrees.
what? You said 33.7?
Mm-hmm.
And that's what I got as well. If we wanted to find angle, let's go to angle B real quick. Now angle B, you'd have to imagine that these lines are extended a little bit here, right? Because this is actually AB's angle, the 26.6. And this is actually BC's angle, 82.9. So if we wanted to find this angle, which is of course vertical to this one, we'd subtract those and we would get
56.3.
good, 56.3, and that's your angle B. Then finally for angle A, what we already know right here is the 26.6 degrees. We also know that this angle is 116.6 degrees here. How much is left for this little piece?
36.8 degrees.
How much?
36.8.
That's not what I have.
Oh,
We got 116.6 here. How much would be left to finish the straight angle?
63.4.
63.4. But we understand that the angle at A is actually the 63.4 leftovers from the 116.6 and the 26.6. So how big is angle A?
90 degrees.
Exactly 90 degrees. That's interesting. We're going to come back to that idea here in just a moment. Sounds like you got angle C. Looked like you were recalculating B. Questions, comments?
I had added the 82.9 and 26.6.
You added them together. I got you, instead of subtracting. Okay, does it make sense why? Because really, again, we could think of, for instance, this angle of inclination as being here. So you could think 82.9 here. That might have worked as well. And then A has this angle of inclination, which is the same as this one. Subtract the whole minus the part to leave you with this part. We could have done alternate interior angles there instead of corresponding. That could have worked. Does it make sense how to use those geometry ideas, though? How could I check my answers?
I'm on together to see if they add up to 180.
Do they add up to 180 degrees? Yes, they do. And so we are good to go here. All right, questions on this? All right. Well, next section of your notes, speaking of this 90-degree angle, if there were a perfect 90 right here, obviously that means, first of all, that my triangle is a right triangle, which means if I had found the length of this line, the square of this length would be equal to the sum of the squares of these two lengths. But what about these two lines themselves? Since they form a right angle, we could say that AB and AC would be what to each other? Since they meet to form a right angle.
No.
Big fancy word. Perpendicular. They'd be perpendicular to each other. Notice their slopes. A half, negative 2 over 1. What do you notice about their slopes?
Negative reciprocals.
They are negative reciprocals of each other. As you say that, you said that as if you remembered hearing that. For instance, in Algebra 1 and Algebra 2. Next thing in your notes, parallel and perpendicular lines. Parallel and perpendicular lines. Now, obviously in geometry class, we defined parallel lines as lines which never intersect because they are everywhere the same distance apart. Well, what would give me a line, for instance, if I had this line BC and I had another line exactly parallel to it, what would cause these two lines to always be the same distance apart? Well, obviously, if their corresponding angles were equal, correct? These corresponding angles are angles of inclination. So if they have equal angles of inclination, well, to have equal angles of inclination, they would have to have equal. What does angle of inclination depend on?
The slope.
The slope. So if they have equal angles of inclination, that would be because they have equal slopes. So if you will, get this down, that parallel lines have the same slopes. Parallel lines have the same slopes. Again, yes, they never intersect. Yes, they're everywhere the same distance apart. But for our purposes, what we're going to remember about parallel lines in this class is they have the same slope. For perpendicular lines, notice they have exact opposite slopes. One slope, it would have to be positive. The other slope would have to be negative. Two positive slopes can't be perpendicular. Two negative slopes can't be perpendicular. One's got to be positive, one's got to be negative, and the rise and run of one has to be countered by the run and rise of the other. Does that make sense? Or run and fall, right? The rise of one has to be the run of the other. The run of one has to be the rise of the other in order for them to be perfect opposites. So we said negative reciprocal slopes. And again, this shouldn't be new to you. As you're hearing it, you should be like, oh, yeah, I remember learning that in Algebra 1 and Algebra 2. So for instance, turn to page 210. Page 210. Let's take a look at some exercises here. Go ahead and read number 1 if you would, sir.
Find the slope of a line parallel to the line through the plane.
All right, so in letter A, they give us a couple of points, and they want the slope of a line that is parallel. Well, anytime in this class we see parallel, I'm going to think 2 words, Quentin.
Same slope.
Same slope. All right, so what is the slope of the line there in 1A? Find it, call it when you've got it. If you're watching, go ahead and pause it until you've got it.
Negative 11 halves.
Negative 11 halves. Good. The line in letter A has a slope of negative 11 halves. So what would be the slope of a line that's parallel?
6 11ths. No, parallel. Negative 11 halves.
Negative 11 halves, because parallel means
Same slope.
same slope. So if the line in letter A has a slope of negative 11 halves, a parallel would have a slope of negative 11 halves. All right, letter B, find the slope of the line. Again, if you need to, pause it for a moment. You got it?
5.
5. All right, so what would be the slope of a line that's parallel to the line in letter B?
5.
5. All right, letter C, find the slope.
4 over 0.
4 over 0. Anything over 0 is
Undefined.
undefined. So the slope of our line is
0. Oh, undefined.
undefined. That means a parallel line is going to have what slope?
Undefined.
Undefined as well. How about letter D? Find the slope of that line.
0.
And you have
0 over 14.
0 over 14, or in other words, just
0.
0. So what's the slope of a line that's parallel to that one?
0.
0 as well. By the way, undefined lines are
Vertical.
Vertical. So letter C, the line is a vertical line. Obviously, all vertical lines are going to be parallel to that one. And then letter D, a zero slope line, is horizontal. Of course, all horizontal lines are going to be parallel to each other as well. Questions on number 1? All right, number 2. Read it for us.
Find the slope of a line perpendicular to the line 3 points above.
All right, so we already found the slope of letter A to be negative 11 halves. We said a parallel line is going to have a slope of negative 11 halves. What would be the slope of a perpendicular?
2/11.
Positive 2/11. Letter B, what would be the slope of a line perpendicular to that line?
1/5. Wait, negative 1/5.
Because perpendicular lines have what kind of slopes?
Negative reciprocal.
Negative reciprocal slopes. So negative 1/5, just as letter A was positive 2/11. Letter C, what would be the slope of a line perpendicular to a line with an undefined slope?
0 slope.
Good, 0 slope. Perpendicular to undefined or perpendicular to vertical would be horizontal. So perpendicular to undefined would be 0 slope. So on letter D, the line they gave us had 0 slope. What would be the slope of a line perpendicular to that?
Undefined.
Undefined slope. Good. Questions on that. All right, number 3. Go and read what we're going to be doing here.
Find the slope of the altitude on each side of triangle ABC.
All right, find the slope of the altitude, it says. Now, from our geometry class, we remember altitude means...
It goes from the midpoint of the vertex.
That'd be median. So, for instance, the median here would go vertex to midpoint. But what about the altitude?
From midpoint to mid? No.
That would be no-name line. Perpendicular. The height, if you will, or the perpendicular. So this is what an altitude would look like here. Represented, by the way, by the letter H. We think height, but the biggest reason is if my sides are A, B, C, then this line here could be referred to as the altitude on B. We can't use A sub B. A already means side A, so H is used instead, for instance. But it wants the slope of the altitude. Well, again, let's refresh. Altitude means
Perpendicular.
Perpendicular. So, therefore, when we need the slope of the altitude, I need to be thinking 3 words.
Negative reciprocal slope.
Negative reciprocal slopes. Let's go ahead and draw a rough sketch triangle here for letter A on number 3. Doesn't have to be drawn to scale. Did not catch with foot. Did not catch it all. Just broke chalk again. The worst luck. Put a whole stick of chalk in the chalk holder. Always break the chalk. There you go. You lose some, you lose some, I always say. All right, letter A. I always say that. I really do. All right, letter A on number 3, we got the point 1, 0. Letter B, we got the point negative 3, 4. And letter C, the point negative 1, negative 3. Now, obviously, there are how many altitudes that may be drawn in a triangle?
3.
3 altitudes. All right, let me get the blue chalk here as well. All right, so we've got the altitude straight down to AB. We could call this H sub AB. We've got the altitude, of course, from A that goes straight across. We could call this H sub A or BC. And we've got the altitude that comes from B over here to AC, so we call this H sub AC, right? All of these are perpendicular here. Notice they all intersect. Do you remember the point where the 3 altitudes intersect? It's the orthocenter. Remember, ortho means straight. So these are straight down or straight across to the other side. So let's start with this altitude on BC. If I want to know its slope, and it's perpendicular, so I'm thinking negative reciprocal slope, I would first need to find the slope of BC. So let's find the slope of BC and call it when you've got it.
Negative 7 halves.
Negative 7 halves. Therefore, the slope of the altitude on BC has to be what? 2 sevenths. Notice the notation. M sub H sub BC. All right, little m for slope, little h for altitude, BC meaning on BC. All right, let's find now the this altitude's slope here. Well, in order to find the slope of the altitude on AC, I first need to find the
Slope of AC.
slope of AC. And what do we get for the slope of AC?
3/2.
3/2. So therefore, what is the slope of the altitude on AC?
2/3.
Careful.
Negative.
Negative 2/3. Negative reciprocal slope. All right, now let's find the slope of this altitude, the primary altitude, right? If we consider AB to be the base, well, that means first we need to find the
Slope of AB.
slope of AB. And what do we get for the slope of AB?
-1.
Yes, -1. 4/-4, which gives -1. Therefore, what is the slope of the altitude on AB?
1.
+1. There we go. Make sense? Questions on what we did here on 3A. Go and do 3C at your seats. Go and do 3C at your seats. Finding the slopes of the three altitudes. The slopes of the three altitudes. Lots of good geometry terms review here, fact review. Saw Miss Morse coming in today, Jamie, and I don't know that the seniors would get any of this simply because she doesn't teach you guys anymore once you get to senior year, which I'd be very sad. I'm glad I get to teach you guys twice a day. It's awesome. But anyway, she brought in king cake. They're celebrating Mardi Gras down in Louisiana, where she's from. But anyway, so we'll go Mardi Gras colors here. We've got this primary altitude here. We've got a secondary altitude, something like that, and then we'll go with a third altitude, something like that. It's a little wobbly, got scoliosis, but other than that, we're good to go here. Again, let's start with the yellow one here. So we're looking for the slope of the altitude on AC, this yellow altitude. And of course, in order to find the slope of this altitude, Quentin, I first had to find the slope of AC. AC's slope was
8/3.
for AC.
Oh, I wrote down the wrong C. I wrote down the C from
Oh, okay, so that means two of your answers are going to be off then. Oh, okay, take just a moment to recalculate. I'm curious how well the purple, green, and yellow show up on the screen of the computer. I'll have to go back and watch this part of the video to see how well the different colors pop.
6/10.
I don't got that either. I got a 5 minus -1 is 6. But that means I've got a 2 minus 8 is
10.
2 minus 8? Was that a -8, -1? And I copied it wrong?
Positive.
Okay.
Sorry. So 6.
Well, -6, right? 2 minus the 8. So we start with the 5, got to start with the 2. So our slope should have been,
-1.
so what's the slope of the altitude?
1.
+1. All right, let's go with the purple altitude here, the slope of the altitude on AB. And of course, first we have to find the slope of
AB.
AB. Now that C wouldn't have messed up. So you should have the correct slope here. You had
1.
1. So if the slope of AB is 1, what's the slope of the altitude?
-1.
-1. Now that's interesting. This has a slope, this line right here has a slope of 1. AC has a slope of -1. What does that mean about AC and AB? They themselves must be perpendicular to each other. Right? So apparently we've got a little right triangle. Again, we could use the distance formula, use Pythagorean theorem to check, but apparently that's what we've got going on here. Which means if we drew, right, if you drew a right triangle, perpendicular sides, then the altitude here and this altitude here, these altitudes, the purple and yellow lines, actually are the yellow and purple lines. So not clearly drawn to scale here. All right, finally, let's get our final altitude, and that's the slope of the altitude on BC. Recalculate BC's slope. -1/5. So since BC's slope is -1/5, the altitude on BC is going to have a slope of 5. All right, questions on that? All right. Again, kind of interesting here. See, with the right triangle kind of throws things up. That's weird to think that this line is actually this line, and this line is really this one. These are the same line, and those are the same line. We can't trust our eyes. All right, let's go to number 4, and read number 4 if you would, sir.
Given A 0 to B -3 -7, C 3 -4, D -6 -1. Say which of the lines AB, AC, AD, BC, BD, and CD are parallel and which are perpendicular.
All right, so give us 4 points, right? And if I give you 4 points at random on a plane, you could draw 1, 2, 3, 4, 5, 6 different lines, correct? So we've got point A, point B, point C, point D. Again, 4 lines you could draw. The question is, which of those lines are parallel, which are perpendicular? Well, to know anything about parallel or perpendicular, you got to know slopes, right? If they're parallel, they're going to have the
same slope.
Same slope. And if they have the same slope, they're going to be parallel. If they're perpendicular, they're going to have negative reciprocal slopes. And if they have the same slope, they're going to be parallel. But if they have negative reciprocal slopes, they're going to be perpendicular. I tried. Good job. You were ready. All right, so A is, looking at number 4, 0, 2. I was having so much fun, I forgot where we were. B is -3, -7. C is 3, -4. D is -6, -1. At your seat, find the slope of all 6 lines. You don't necessarily have to find them in the same order that I do. Shout out to Chris. Questions like that were so much more fun when he was around. I'm not sure that was much of a shout out, my bad. All right, so let's see what we got here. For AB's slope, you had?
-3.
I had a positive 3. 2 minus -7 over 0 minus -3. I got a 9 over 3 or positive 3 for that slope. What about BC's slope?
-2.
BC?
Oh, BC, sorry.
Yeah, sorry, I'm going out of order here. I'm going on order with what I have.
1/2.
That is correct, okay. What about CD's the next one I've got written down?
1.
That's not what I had for CD. I've got -1 minus -4 over -6 minus 3. Add the inverse. I've got a 3 over -9 or -1/3. Are you sure? CD? Are you looking at CD on your paper?
Mm-hmm.
Okay. AD?
AD, 1/2.
That's correct. All right, what about AC?
-2.
That's correct. And what about BD?
-2.
And that's correct as well. Okay. All right. Now what's interesting here is this cannot possibly be the correct shape. Because notice AC and BD are listed as being parallel, so they can't be diagonals in the quadrilateral. So apparently we've got a side of AC parallel somehow to another line that's BD. Also, so we could say that AC is parallel to BD. So that's one thing we know. There's another pair of parallels though.
BC and AD.
BC and AD are parallel. Well, again, BC and AD can't be like this, so maybe we put A here and C here. AD and BC are parallel. So apparently my quadrilateral would be ACBD or ADBC, depending on how we chose to name it, because we also know you said that BC and AD are parallel. I think that's all the parallels we have, right? These two and those two are my parallels. What about perpendiculars? AB and CD are going to be perpendicular. AB perpendicular to CD. So the diagonal and the other diagonal are perpendicular. Not quite drawn perfectly here on my paper. Now that's interesting because do you remember if opposite sides are parallel, which we have a
rectangle? No.
Maybe more generally a opposite sides parallel? Parallelogram. But if the diagonals of a parallelogram are perpendicular to each other, obviously if they bisect, well, all parallelograms bisect. If they were perpendicular,
Square?
too specific. Rhombus. So all rhombi have a perpendicular diagonals. So we at least know now, we knew from this, okay, it's got to be a parallelogram. We know from this, okay, it's got to be a rhombus. But we have more perpendiculars.
AD and AC.
AD and AC
And BD.
are perpendicular.
AD and BD.
AD and BD are perpendicular. So AD and AC are perpendicular. Well, we already knew it was a parallelogram, and now we know there's a right angle. That makes it a parallelogram with a right angle?
No.
Parallelogram, but you put a right angle in it instead.
Oh, rectangle.
Rectangle. But we already said it was a rhombus. How can it be a rhombus and a rectangle? Remember, rhombus involves the sides all being equal. And it's a rectangle. Apparently, this thing must be a square. We've got that other right angle here, ADBD, right angle, but there's another right angle or two.
BC and AC.
BC and AC. Perpendicular, and also
BD and BC.
BD and BC. Perpendicular. So apparently we have a square. If we were to actually plot these points and connect them in that order, CBDA, we would end up with a square. Right? Questions on that? Again, some geometry concepts that we tie back into the algebra that we do. Let's take a look at number 5 and readeth numero 5 for us.
Without graphing, determine if the points 3, 6, 8, -4, and -6, 24 do or do not lie on a straight line.
Whoa, they gave you 3 points?
Yes.
They say determine if they do or do not lie on a straight line. Now, normally, Quentin, if I just put 3 dots on the board, any 3 points, 3 points forms a triangle. The only way in which these 3 points would actually fall along the same line or be in a straight line is if the slope between these two is the same as the slope between those two as the slope between those two, right? Really, if you know 2 slopes match, the third one's going to have to match, but it could be used as a check. So what we want to do then is, given those 3 points, 3, 6, which we'll just call this Q as a random letter. We'll say 8, -4, maybe name that one, I don't know, D, just to be random. And -6, 24, I don't know, A, why not? Let's find the slopes of our 3 lines. QD, not QT, and DA, like district attorney, and QA, as in question and answer. If the 3 slopes all match, then they must all lie along the same line. By the way, remember the term for all lying along the same line? From physics. We use it to describe vectors specifically. Collinear. If the points are collinear, they will all lie in the same line. You get to college and start using terms like that, your professors are like, oh, this is a smart one. Oh, I like him. And you're like, well, all these points, if they got to be in the same, then they look at you weird and they just look forward to flunking you out of their class because they don't like you anymore. I tell you, gotta kiss up, gotta know the system. Or if you go to a Christian college, all the professors love you. Somewhat. If they know who you are. If you're like student number 106527, all right, what is QD's slope?
-2.
What is DA's slope?
-2.
And what is QA's slope?
-2.
So, do the 3 points all lie in the same line?
Yes.
Yes, of course they do. All right, questions on that? All right, drop down to number 6, and let's do letter A here. Read number 6.
Show that the median to the longest side of triangle ABC is also an altitude.
Read that one more time.
Show that the median to the longest side of triangle ABC is also an altitude.
Show that the median to the longest side. Okay, remember, what's a median?
It goes from the vertex to midpoint.
Okay, so going from vertex to midpoint of the longest side. So what am I going to have to do right up front? Figure out which side is the longest side. Okay, so how do we figure out for triangle ABC? Again, not necessarily drawn to scale here. I've got 1, 5. I've got 4, 1. I've got 5, 8. How do I figure out which one's the longest? Find all 3 lengths. Go and do that at your seat. Let's find all 3 lengths and figure out which one of these is the longest side. This curved line is kind of bugging me here. Not OCD or anything. That's better. All right, so what is the length of AB first of all?
5 units.
5 units, okay. What is the length of BC?
5 times square root of 2 units.
5 times the square root of 2 units. Oh, I see where this is going. And what is the length of AC?
5 units.
Also 5 units. Okay, by the way, what figure do we have here?
45, 45,
Yeah, apparently this is a 45, 45, 90 right triangle. Okay, so the longest side is BC. This is the longest side. And it says show that the median is also an altitude. We'll show that the median, again, you said median goes from vertex to midpoint. So the next thing I need to find is the midpoint of BC. And what are the coordinates, of the midpoint?
4.5.
I hate decimals.
9 halves. 9 halves.
9 halves. Okay, lovely. All right, by the way then, I'm going to rewrite, because this median right here goes from A to the midpoint of BC. I'm going to rewrite 1 as how many halves?
2 halves.
2 halves. And I'm going to rewrite my 5 as
10 halves.
10 halves. All right? It says, show that this median is an altitude. What does altitude mean?
Perpendicular.
So they're saying, show that this median is perpendicular to BC. Well, whenever I think perpendicular in this class, I need to think 3 words.
Negative reciprocal slope.
All right, so therefore I need to find 2 slopes. First, the slope of?
The median.
The median, right? I need to find the slope of A to the midpoint of BC, and I also need to find the slope of BC. And if these are negative reciprocal slopes, then my median is an altitude. All right, let's start by finding BC because that's easier. What is the slope of BC?
7 over 1. So, yeah.
7 over 1 or just 7, okay? Now for the slope of the median, we need to find a change in y.
1 half.
1 half. Over the change in x.
7 halves.
Well, but if we're going this way, 10 halves minus 9 halves, we need to say 2 halves minus 9 halves.
Negative 7 halves.
Negative 7 halves. And if I multiply by the, which is negative 2 sevenths, cancel, what do I get for my slope?
Negative 1 7.
Negative a seventh. And are those negative reciprocals? Then my median is indeed perpendicular to my side, making it an altitude and a median at the same time. By the way, remember that's going to be true in any isosceles triangle. Remember, in any isosceles triangle, the median, line to the midpoint of the base, will also be the altitude. And it will also bisect. Though, if we wanted to, I suppose we would find the lengths of these two and show that they're equal and show that that's also true. We got a few minutes. Let's do it. Let's rewrite my 4 and 1 as
3 halves and 2 halves.
and my 5 and 8 as
10 halves and 16 halves.
all right, and what do we get for this piece? Let's do the change in x
1 half.
squared.
2 4.
Be careful, square of a half. Square 1, square 2.
Oh, 1 4.
1/4, and then here the change is
7 halves.
square it.
49 4.
49 fourths. So we end up with the square root of 50 fourths. We could reduce that, but I don't really care as long as this comes to a square root of 50 fourths. What's the change in x?
1 half.
1 half squared is a fourth. Change in y
7 halves.
squared is 49 fourths. Sure enough, we can see that's going to be another square root of 50 fourths. So yes, this line is the median, it is the altitude, and it's also a bisector, specifically the perpendicular bisector of that side. So all kinds of geometry stuff coming through for us here. Questions at all on this? All right, your homework for this evening is, I'm going to have to write it on the board here for you, so let me come over here. First of all, I want you to do page 210, number 3D. Page 210, number 3D. I also want you to analyze some lines here. Given that R is 3, 7, given that N is 1, negative 3, I want you to find the length of Rn, the midpoint of Rn, the slope of Rn, and the angle of inclination of Rn. Also, move this out of your way as you're copying. Oh, and be lazy here. I also want you to find the slope of a line CT if CT is parallel to Rn. I also want you to find the slope of Ra if Ra is perpendicular to Rn. So 6 things you're finding in addition to page 210, number 3D. Given R and N, find the length, midpoint, slope, and angle of inclination of Rn. Also find the slope of Ct if it's parallel to Rn, and find the slope of Ra if it's perpendicular to Rn. All right, we'll take a look at that in our next lesson. Have a wonderful rest of your day, and when the bell rings, you'll be dismissed. Jamie, hope you're feeling better soon and able to rejoin us tomorrow.